The American Petroleum Institute presents Principles and Operation of Production Separators, Part 1. Produced by Shell Oil Company. Distributed by Petroleum Extension Service, Industrial and Business Training Bureau, Division of Extension, the University of Texas at Austin. Rights acquired by the American Petroleum Institute, October 1974. This class is an introduction to production separators, which will show you how separators work, how they are built, and how to troubleshoot problems. After these vessels are placed in service, they generally do not give much trouble, but when it does occur, the operator should be able to find the problem. He can make adjustments, repair a valve, or get help from an automatic control repairman if the trouble is in the controls. Before we begin talking about actual production separators, let's look at a simple separation example using gas, oil, and water, the three liquids produced from most oil wells. When a mixture of these fluids is placed in a glass jar and allowed to sit quiet, the oil, being lighter than water, will float to the top of the water. The gas, being lighter than oil, will rise to the top of the oil into the empty space above. This separation is achieved by the difference in gravity or weight of each fluid. Production separators do the same job, except they are built to handle a continuous flow stream and have features to improve separation efficiency under flowing conditions. These features will be discussed later in this presentation. Most platforms have a series of production separators. Starting at the left, a high-pressure separator which separates the gas from the liquids and then dumps the liquids to a medium-pressure separator which removes more gas and then dumps the liquids to a low-pressure separator that removes even more gas and then separates water from the oil. The water from the low-pressure separator is dumped to the skim tank, with the oil being dumped to the wet oil surge tank. You're probably familiar with one or all three general types of separators: the horizontal, vertical, and the spherical. Horizontal separators, such as shown here, are generally used for high pressure and medium pressure service. The horizontal separator may have two barrels, that is, one stacked upon another. This allows for larger surge capacity and has a more stable liquid level control than does the single barrel horizontal separator. Vertical separators, such as this one, are generally used for low pressure service, but on some platforms are used for high and medium pressures also. The spherical separator is more compact and cheaper, but it has limited separation space and liquid surge capacity. It is therefore used mostly on low-volume remote platforms. From the outside, the separator appears to be only a tank with piping, valves, and instruments hooked onto it. There is, however, more than meets the eye, so let's begin by looking inside a separator. The production from the wells, which is a mixture of oil, water, and gas, enters one end of the separator. Upon entering the larger area, the well stream slows down and separation begins because of the difference in gravity of the fluids. The separators on your platform will usually have features like those we will now discuss. The first of these features is an inlet diverter. It is used to help break up the incoming liquid so that entrained gas can separate from the liquid easier. Straightening vanes or stacked plates just past the inlet diverter are often used. These serve two purposes: one, to reduce turbulence in the gas stream, and two, to help remove liquid entrained in the gas. All separators will have a mist extractor near the gas outlet for final scrubbing of liquids from the gas before leaving the separator. The separator will have some means of reducing liquid turbulence in the main body so that proper separation may take place. This is accomplished with baffling or weir boxes. These features also provide a calm area in the vessel for the operation of level controls. This completes the list of the major internal features of a separator. They are 1. The inlet diverter for initial separation. 2. Straightening vanes for reducing gas turbulence and for removal of liquid droplets entrained in the gas. 3. The mist extractor for the final scrubbing of the gas. And 4, finally, baffling and weir boxes to reduce liquid turbulence and to provide a calm area for separation and liquid level control. The vertical separator has the same internals as a horizontal separator, but the arrangement is a little different. Let's look at the operation and internal features by starting at the upper left. The liquids and gas enter the separator through the inlet nozzle and change direction after striking the inlet diverter. Separation of gas from the liquids begins here, and the gas rises up the separator and through the mist extractor to remove any remaining droplets before leaving the separator. The liquids fall from the middle part of the separator to the bottom. Baffling, shown in the lower portion, provides a calm area for the level control float. A pressure equalizing line from the mist extractor to the float chamber is needed to maintain maximum pressure at the liquid outlet and to drain the liquids from the mist extractor. A three-phase separator removes gas from the liquids and then separates oil from the water. Let's follow the flow in a three-phase separator starting at the inlet on the upper right side. The inlet diverter changes the flow direction to help separate the liquids from the gas. The gas flows upward through the mist extractor and out of the separator. The liquids drop downward into the first compartment, where the oil rises to the top and spills over the weir into the oil compartment. The float in the oil compartment operates a controller and dump valve to let the oil out while maintaining a level of oil over the outlet. The water which settles out of the oil in the first compartment is controlled by an interface float, which is the level where the oil float contacts the water. The interface float and controller operates the water dump valve to prevent oil from leaving at this outlet. Now that we've learned what is inside production separators, let's examine the external features. The first external feature we shall look at is the pressure gauge. The purpose of this instrument is for the operator to check the operation of his equipment and to aid in the setting of back pressure controls. The next external feature of the separator is the gauge column. The purpose of the column being, of course, to permit viewing of the liquid level and to assist in the setting of level controls. The gauge columns are connected to the vessel by gauge cocks. The gauge cocks have internal check valves for safety measures and to prevent fluid loss in the event the gauge glass is broken. The recommended practice for putting gauge columns into service is to open both cocks slightly. This permits a gradual equalizing of pressure within the gauge column with the pressure of the vessel and will minimize the chance of vapor locking of the column, which could cause the column to show a false liquid level. After the pressure has equalized, open both cocks all the way. The gauge cocks must be completely open so the built-in check valve can seat and stop the flow if the gauge glass should break. The next external feature is the safety relief valve, located on top of the separator. These valves are designed to relieve the pressure when the pressure inside the vessel exceeds a set point, which is always below the design working pressure of the separator vessel. Should the pressure rise to the set pressure of the safety relief valve, the valve opens and releases the gas to a flare line. On most separators, two safety relief valves will be found, with one set at a slightly lower pressure than the other. The next external feature is the back pressure control loop. Without such a means to hold the right pressure, the separator and other equipment downstream of it will be in a constant upset condition. This would cause improper separation, carryover of liquids with the gas, and other undesired effects. This slide illustrates a simple back pressure control loop consisting of a controller and a control valve. The back pressure control loop works as follows. The controller, 1, is set by the operator to maintain a constant pressure. The controller senses the pressure of the separator at point 2, which is upstream of the control valve, 3. If the separator pressure increases above that which has been set in the controller by the operator, the controller, 1, will change its pneumatic output pressure signal to the control valve, 3, and will open the control valve wider to reduce the separator pressure back to that which the operator has set in the controller. Likewise, if the controller senses a decrease in pressure, it will cause the control valve to pinch down until the set pressure is reached. The next external feature of the separator is the liquid level control. The liquid level must be maintained within certain limits to prevent liquid carryover in the gas stream, which would result from a high liquid level, or to prevent gas from leaving through the oil outlet, which would result from a low level. You now are looking at an arrangement of a liquid level control consisting of a float, a controller, and a control valve. This type level control is used to maintain a constant level at all times in the vessel. This liquid level control works in the following manner. Changes in liquid level cause the float, 1, to move and exert a torque or force on a metal tube which connects the float to the controller, 2. This change in torque causes the controller to change its output pressure signal to the control valve, 3, and opens or closes the valve to restore the liquid level to the desired height in the vessel. The pressure and liquid level control loops regulate the operation of production separators. It's important that you understand the basic operation of the controller and the control valve in order to make routine adjustments and service checks. This is a Fisher-type controller and is typical of several different makes used in the industry. The controller is the brains of the control loop. It continuously senses the pressure or the liquid level in the vessel, compares it with a previously set value, and operates a control valve to restore the pressure or level to the desired value. The level can be raised by turning this adjustment knob in the liquid level controller in the direction of the arrow. The level can also be lowered by moving it in the opposite direction. Before any adjustment is made, the separator gauge glass should be blown down through the bottom drain valve and put back in service to make sure that you're not getting a false level. Pressure controller adjustments of the set pressure is done in a similar manner. To raise the pressure, turn the knob in the direction of the arrow. To lower the pressure, turn in the opposite direction. These adjustments must be made gradually. This is the basic controller function, that is, to control the liquid level or pressure. The other features of a controller you'll need to be familiar with for troubleshooting is the flapper, which covers the nozzle. The flapper and nozzle control the output air signal pressure to operate the control valve. The control valve may be operated or stroked by carefully holding the flapper on the nozzle or by lifting it off with your finger. Handle the flapper carefully to prevent bending or distorting the flapper or linkage. By using the flapper to stroke the control valve, you will not upset the control point, and the level or pressure should return to the preset point without changing the adjustment knob. Pneumatic controllers often have additional features, such as proportional band and reset. Their functions and operation will not be discussed in this presentation. These adjustments should be made only by a qualified instrument mechanic. As operators of this equipment, you will normally be required only to adjust the control set point. Each controller is equipped with an air filter regulator to supply clean air at a constant pressure for control operations. It is a simple spring-loaded pressure-reducing regulator with a filter and collection chamber on the bottom to trap solid particles and free liquid. It is very important that this unit be checked at least once each day if the air supply is wet or dirty to prevent fouling the controller. To check the filter, open the petcock on the bottom and drain the water. Continue bleeding until only dry air escapes. Then close the petcock. If the supply air gauge on the controller fluctuates or does not maintain the proper pressure, the filter probably needs to be cleaned or replaced. Now let's direct our attention to the other major part of the control loop, the control valve. This is a cutaway of a typical control valve. Note that the major parts of the valve are identified. Starting at the top, there is the control air inlet, the diaphragm, the spring, the yoke, and the index to show the position of the valve. These items make up what is commonly referred to as the actuator or motor of a control valve. Next, the valve body and the internals of the valve, commonly referred to as valve trim. These are the stuffing box, the valve stem, guide bushings, inner valve, and valve seats. This particular valve has a double port. That is, there are two ports with two inner valves and two valve seats. This valve is also a normally open valve. That is, without any output air signal pressure from the controller to the diaphragm, the spring will hold the valve in an open position. When enough air pressure from the controller is introduced to the diaphragm to overcome the spring tension, the valve will begin to close. When enough air pressure is applied, the valve will completely close. On a normally open valve, such as the one just shown, the spring holds the valve open when there is no air pressure. Whereas on a normally closed valve, the spring will hold the valve closed until enough air pressure is applied to overcome the spring tension. Note that here the air is applied below the diaphragm. The trim of a valve may be reversed so that the action of the valve will be just the opposite. This now completes our review of the major external features of a production separator. These features are the pressure gauge to indicate the internal pressure of the separator and to set the back pressure control valve, the gauge column for viewing the liquid level and to set the level controls. We've seen that it's important that both these features, the pressure gauge and the gauge column, are in good condition. Else how could you know that your equipment is operating properly? The next feature was the safety relief valve to prevent overpressure of the vessel. Then we looked at the back pressure control required to maintain a constant pressure on the separator, and the liquid level control to maintain a proper operating level in the vessel. Then we looked at the main components of the back pressure and liquid level control loops, those being the controller and the control valve. Inside the controller, we saw the adjustment knob for raising or lowering the pressure or liquid level, and the flapper and nozzle that controls the output air to the control valve. The operator may stroke the control valve by carefully holding the flapper on the nozzle or by lifting it off with his finger. By this method, you will not disturb the set control point preset in the controller. Then we saw the supply air regulator. Each day, open the petcock to bleed any water that may have collected in the regulator. Now that we've covered the features of a typical production separator, we're ready to examine the common operating problems experienced with offshore production separators and discuss the actions you can apply to correct these problems. The problems we will cover will be that of low liquid level, high liquid level, low pressure, and high pressure in the separator. Almost all problems experienced with production separators will result in the liquid level or the pressure becoming excessively high or low. First, we will tackle the problem of low level in the separator. This problem is usually caused by one of three things. One, the fluid dump valve could be opened too wide, or the trim in the valve might be cut out, allowing fluid to continue to be dumped even with the valve fully closed. Two, the drain valve might be open or leaking. Or three, there is no fluid coming into the vessel. If you find a low level condition in a separator, check the gauge column to make sure you're not getting a false indication, then proceed with the following steps. First, check the fluid control dump valve and the vessel drain valve to see if they're open. If the drain valve is open, close it. If the fluid control dump valve is open, first, partially open the bypass valve, and then second, close the block valves on both sides of the control dump valve. Set the correct level in the separator by adjusting the bypass valve. Then check the controller supply air pressure gauge to be sure the controller has supply air. Confirming this, try to stroke the valve with the level controller flapper. If the controller properly opens and closes the valve was probably stuck in the open position. Stroke the valve several times to be sure it no longer sticks open and has a smooth action. If it does continue to stick, correct the cause of the binding. The valve stem packing may be too tight, or the valve might require lubrication. Next, return the valve to service by first opening the block valves and second, closing the bypass. Watch the liquid level in the gauge column when changing from bypass valve to the control valve. If a low level condition continues to exist, then determine if fluid is flowing into the vessel. If there is fluid coming in, then the fluid control dump valve is probably leaking and will require repair. So if you have the problem of low level, check for these three things. 1. The fluid dump valve, to see if it is hung in the open position, or perhaps the trim is cut out, allowing the fluid to be dumped even with the valve fully closed. 2. Check the drain valve to see if it might be open or leaking. And 3. Check to see if there is fluid coming into the vessel. Next, we will look at the problem of high level. This problem is usually caused by one of three things. 1. The fluid control dump valve could be closed, or it might be plugged with sand or sludge. 2. One of the block valves around the fluid control dump valve might be closed. And 3. The inlet valve to the next vessel could be closed. If you find a high-level condition in a separator, check the gauge column to make sure you're not getting a false indication. Then proceed with the following steps. First, check the fluid control dump valve to see if it might be closed. If it is closed, check the instrument air supply gauge on the controller. If the instrument air supply is okay, attempt to stroke the valve with the controller. If it doesn't open and the fluid control valve is a normally closed valve, the valve actuator diaphragm may be ruptured and will have to be replaced. Second, if the fluid control dump valve is open but there's no flow through it, it may be plugged with sand or sludge. If it is, open the bypass and close both block valves. Control the liquid level with the bypass valve. Then remove the control valve and clean it out. If after cleaning the valve and returning it to service, the level in the separator remains high, bypass and drain the separator, then clean it out. Third, it might be possible that one of the block valves around the fluid control valve is closed. If it is, make sure that the next vessel or other vessels downstream are okay before opening it. And fourth, if the high level still exists, check the inlet valve and outlet valves of the vessel the liquids are dumped into. If one of these is closed, check to make sure that this vessel is okay before opening it. So if you have a high level, check for these four things. 1. Check to see if the fluid control dump valve is closed. If it is not closed, but there is no flow going through it. 2. The fluid control dump valve might be plugged with sand or sludge. Or 3. One of the fluid control dump valve block valves could be closed. Or 4. The inlet valve to the next vessel could be closed. The next problem we will look at is that of low pressure in the separator. This is usually caused by a malfunctioning back pressure control or a leaking safety relief valve, or possibly the inlet valve to the separator is closed. First, check the back pressure control valve to see if it's open. If it is open, attempt to stroke the valve with the controller flapper. If the valve will not operate, partially open the bypass valve and close both block valves and have the back pressure valve repaired. While having the valve repaired, control the separator pressure by adjusting the bypass valve. A leaking safety relief valve sometimes is the cause for low pressure. A leaking safety relief valve can sometimes be detected by putting an ear to the flare line downstream of the valve and listening for a whistling sound, or by just feeling the line on both sides of the safety relief valve. If the line is several degrees cooler downstream of the valve, it's probably leaking. If you have a leaking safety relief valve, it will need to be checked by an automatic controls repairman. The last check for low pressure is to see if the inlet valve to the separator is closed. If it is, make sure the vessel is okay before opening it. So if you have a low pressure condition, check for these causes: an open back pressure valve, a leaking safety relief valve, or see if the inlet to the vessel is closed. The final problem we will discuss is that of high pressure in the separator. This also can be caused by a malfunctioning back pressure valve, or one of the back pressure block valves may be closed, or a valve to some vessel downstream may be closed. First, check to make sure a block valve is not closed. Then check the gas back pressure valve to see if it might be closed. If it is, check the instrument air supply gauge on the controller. If the instrument air supply is okay, attempt to stroke the valve with the flapper. If it's sticking and won't open, block and bypass the control valve and have it repaired. If the back pressure control valve is okay, check the equipment downstream for a closed valve. Make sure everything is okay before opening any closed valve. So if you have a high pressure condition, check for these causes: a closed back pressure control valve, a closed block valve on either side of the back pressure valve, or for a closed valve on equipment downstream. Now sometimes you will have two of the problems at the same time. With a high level, you may also have a high pressure, and with a low level, you may also have a low pressure. By following the step-by-step procedure, these associated problems can be found and corrected, the same as for only one problem. One of the more common problems of a combination type is that of a high level associated with a low pressure. This is generally caused by the pressure being so low that it will not push the liquids to the next vessel. Check the back pressure valve to see if it might be hung open or the trim cut out, and the controller to see if it's functioning properly. Or the bypass valve around the back pressure valve might have been left in the open position, allowing the pressure to drop, even with the back pressure valve functioning properly. So if you're confronted with the problem, check the back pressure valve to see if it's hung open, or perhaps the trim cut out, and check the back pressure valve bypass valve to see if it might be open. Next, we will briefly point out the major maintenance functions which the operator should perform to keep his separators in good operating condition. Separation equipment will not usually require extensive maintenance. However, the following maintenance items are common requirements and should be performed. 1. Replace broken gauge glasses and pressure gauges as soon as possible. These are essential in knowing that your equipment is functioning properly. 2. Lubricate those valves which are not self-lubricating according to the prescribed preventive maintenance schedule. Lack of or improper lubrication of both manual and automatic valves will eventually cause the valve to fail in its intended function. The results could be a serious upset in the operation of the separator equipment, or worse still, contribute to a serious hazardous condition. 3. Clean the gauge column sight glasses so you can know where the separator liquid level is. Gauge glasses can easily be cleaned internally with a gauge glass brush, water, and a detergent. 4. Periodically check the dump valves. Stroke the valves by holding down or lifting the controller flapper to make sure that the dump valves are free throughout their full operating range. If the valve hangs up or is difficult to stroke, immediately determine the cause. Check to see if the valve stem is sticking in its packing. If not, the cause probably is inside the valve body and may require the valve to be torn down and inspected. 5. Check level controls. Again, stroke the dump valves to see if the liquid level will return to the previous height. If not, the controller may require checking by an individual trained in controller troubleshooting. 6. Check back pressure valves. Stroke the valves to see if they will return the pressure to its set point. If not, follow the same procedures as with the dump valve and correct the problem. 7. Check the air supply regulator for accumulation of water. Open the petcock and drain it until it's free of liquids. During this session, we have looked at the most common operating problems and the means to troubleshoot them. Those problems being that of low liquid level, high liquid level, low pressure, high pressure. We saw that for the problem of low level in the separator, to check 1. The fluid control dump valve to see if it was hung open or perhaps the trim cut out. 2. To check the drain valve to see if it was open or leaking. And 3. To check to see if there is fluid coming into the vessel. For the problem of high level in the separator, check 1. The fluid control dump valve to see if it may be closed or plugged up. 2. Check the block valves on each side of the fluid dump valves to be sure one of them is not closed. And 3. Check the inlet to the next vessel. The problem of low pressure is usually caused by a 1. Malfunctioning back pressure valve. 2. Leaking safety relief valve. Or 3. Perhaps the inlet to the vessel is closed or partially closed. And then the problem of high pressure, which could be caused by 1. A malfunctioning back pressure valve. 2. A closed block valve. 3. A valve on a vessel downstream of the back pressure control valve could be closed. And finally, we looked at normal maintenance requirements that should be performed to make sure the equipment operates more efficiently. These were 1. Replace broken gauge glasses and pressure gauges. 2. Lubricate all valves that require lubrication. 3. Clean the gauge glasses when dirty. 4. Periodically check the liquid control dump valve to be sure it's in good operating condition. 5. Check the liquid level controller by stroking the liquid level control dump valve. Then see if it will return the liquid level to its proper control point. 6. Check the back pressure controller by stroking the back pressure control valve, then see if the pressure returns to the set point. 7. Check the air supply regulator for water.